One of the greatest achievements of humanity is the development of the rocket technology. The Saturn V rocket, developed by NASA, is the largest, heaviest, and most powerful rocket ever built. It stood at a staggering height of about 363 feet, nearly 59 feet taller than the Statue of Liberty. It was launched in the Apollo missions. A typical rocket is made up of four main built-in systems: the structure, the payload system, the guidance system, and the propulsion system. These systems are made up of several minor technical parts, which work together for the rocket to operate perfectly. For a rocket to propel itself to space or other planets, it needs to follow certain scientific laws, particularly Newton's third law of motion. This law states that for every action, there is an equal and opposite reaction. Imagine a balloon filled with air. As the balloon tries to expel the air also passes an equal and opposite reaction and causes the balloon to travel in the opposite direction. This same law of motion occurs to rockets. Rockets also expel gas to produce thrust. The propulsion system of the rocket takes up the largest compartment in the rocket. It contains the fuel, oxidizer, the combustion chamber, and the nozzle. All these parts form the engine of the rocket. To generate powerful exhaust gases, a combination of fuel and oxidizer is burnt in the engine's combustion chamber. After the rapid combustion process, these gases are expelled through a nozzle at the rear of the rocket at high speeds. This shape or type of nozzle is called the convergent-divergent nozzle. As the hot gases are expelled downward, the rocket experiences an equal and opposite reaction, pushing it upward. This force is known as thrust. The greater the mass of gases expelled per second and the higher their velocity, the greater the thrust generated, propelling the rocket forward. The most common rocket fuels include liquid hydrogen, liquid oxygen, and various combinations of hydrocarbons. To control the direction of the rocket, a technical system known as the thrust vector control system is adopted. This is also known as the gimbaled thrust. This is achieved by adjusting the rocket nozzle. By adjusting the direction of the nozzle, the rocket can change its orientation and trajectory. Now, in certain large rockets, a single engine is not enough to lift the rocket off the ground. To help this situation, minor rocket boosters are attached to the main engine. However, when the rocket finally takes off and reaches a certain altitude, the boosters become useless in the process. They are then detached from the main rocket. This is known as rocket staging. Stage separation mechanisms, such as explosive bolts or pneumatic systems, ensure clean separation between stages, allowing the remaining portions of the rocket to continue their ascent unimpeded. Each stage contains its own engines and fuel tanks. As one stage depletes its fuel, it is removed and the next stage ignites. This process allows the rocket to shed excess weight and continue its journey more efficiently. During the last stage, the rocket is capable of traveling at a very high speed, about 18,000 miles per hour. This is several times faster than a bullet. Certain rockets can achieve speeds exceeding 25,000 miles per hour in space. In some cases, rockets are equipped with recovery systems to retrieve and reuse certain components after launch. This may involve parachutes or aerodynamic surfaces that slow the descent rate of the spent stages, allowing them to be recovered intact for future missions. The structural system of a rocket is composed of lightweight yet durable materials such as aluminium or carbon fiber. They form the skeletal framework of the rocket. This system consists of the main cylindrical body, wide fins, and the pointed nose cone. The payload system is the cargo it carries into space. This can range from satellites and scientific instruments to spacecraft destined for distant planets or even humans venturing beyond Earth's orbit. The last of the four main systems is the guidance system. Precision is highly important in space travel. The guidance system of a rocket ensures that it stays on course throughout its journey. Advanced sensors, gyroscopes, and onboard computers constantly monitor the rocket's position and velocity, making real-time adjustments to its trajectory as needed. Rockets are a marvel of human ingenuity. The history of rockets can be traced back to the 13th century in China, where the first recorded use of rockets occurred. These early rockets were simple devices, using gunpowder to propel themselves into the air. Over the past hundreds of years, rockets have developed slowly, with incremental improvements made by various civilizations.